talk about inverse functions now. So inverse functions, there's a lot to, the unit of functions is really big in methods. So there's a lot of weird and wonderful functions that we need to talk through. But inverse functions are kind of a subtype. So essentially an inverse function is just a opposite of the operation with that. So remember, functions are machines. So it's kind of like if a function was let's say if a function was a sewing machine, then the inverse function of that would be a stitch breaker, right? So it's kind of like the opposite of that. Or if a function was a doing construction, then the inverse function would be a house demolisher. So it's just trying to kind of reverse what's previously been done to it. So like this, talking about this here, doubling a function, halving a function. So those two are inverse functions of each other. Okay, so how we actually do inverse functions and actually make it into an inverse function is we take a function that takes x values and now turn them into y values, and then we can take those y values and then turn them back into the exact same x values. So what this means is that we're actually inputting y values into the inverse function, and the outputs will be the original x values. So you can kind of see that here. So the x values get inputted, and then if we inputted the same y values into the inverse function, we should get the same x values. So what that really means is that there's a relationship between the domains and ranges of the function and the domains and ranges of the inverse function. Okay. So let's chat about how we actually do this and actually write out and do the inverse function. So when we're considering something like this, where f of x equals to negative 4x plus 7, and they want us to find the inverse rule, so note they said rule rather than they want to find the inverse function, because if they want the inverse function, we need to include the domain in it as well. But we can kind of chat about, so in terms of the domain and ranges, they just flip, because remember what you're actually doing is you're flipping the values, so it kind of would make sense that you're flipping the sets of values each of that the independent and the dependent value can take, because you're kind of flipping the positions of those two values as well. Awesome. All right, so most importantly, okay, this is the point I want you to remember from inverse functions. If you remember something from inverse functions, just remember this point for me. You must write that I cannot emphasize this enough, that you must write that you need to say, for inverse, swap x and y. Okay, so that is the golden sentence in inverse functions. And in addition to that, you have to let y equal to f of x, okay? Because nobody knows what y is. This is f of x. Okay, so those are the two things you must write at the start. It's often given a mark in methods papers, and if you don't write it, VCA will be very unhappy with you, because they'll say that you've pulled your x and swapping your x and y out of really nowhere. So that's exactly what we're going to do here. So we're going to say y equals negative 4x plus 7, and then we're going to have x equaling to negative 4y plus 7. Amazing. So now, because we want to solve our function, what we're going to do is rearrange for this. So we'll get x minus 7 equals to negative 4y, and y will equal to negative 1/4 x minus 7. Cool. So then we're not done yet, because they wanted us to write the rule of this, right? And we've just written a random y thing. So then we write f inverse x is equivalent to negative 1/4 x minus 7. Cool. Amazing. Another thing I just wanted to kind of talk about briefly, just before we jump into the next section, is if you're doing questions, so this type of question often also does come up a little bit. So there's kind of graphical questions, especially multiple choice types of questions, which are say like they give you a picture and they don't tell you what function it is, but then they tell you to find which picture represents the inverse. The most important thing is literally like if they give you a graph, just literally draw a line on the paper, and then reflect it within the quadrants, and just reflect it across that line. So for example, if we see something like this, we're going to think it looks like this. If it's like bump, 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 it's going to be bump, 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 right? Etc. Like you can kind of work it out from there, but just remember that you need it to be flipped, and it's kind of just like if you're flipping across this line as well. So you just kind of consider this a mirror which they're flipping over. And I feel like that makes life a lot more easier, and it does make life like it does make your maths a bit like it's helpful, and it does make your life a little bit easier in terms of trying to do these types of questions.